Hey friends. Okay, so today is our last lesson on linear systems, and we're going to deal with properties of systems. Now, really, we've been dealing with properties of systems throughout the whole unit. So a lot of what we do today, it'll feel familiar, okay? Some of the conversations that we're going to have, we've already had. The purpose of this, though, is to think to ourselves, like we've already talked about the fact that I could have one solution, or I could have no solutions, or I could have infinite solutions, right? I have one solution if the slopes are different. I have no solutions if the lines are parallel. So that would mean the slopes are the same, but the y-intercepts are not, okay? Or I could have infinite solutions if I end up with overlapping lines, and to know that the slopes would be the same and the y-intercepts would be the same. Okay, we've had all those conversations before. But what we kind of want to look at in today's lesson, I mean, some of it will be review for you, and some of it will be, can we then determine whether there's one solution or no solutions or infinite solutions without actually going through the process of solving the system? Okay, so that's the one tiny little newer thing to this, but the rest is going to feel very, very comfortable. Okay, so what I would like you to do is I'd like you to solve this graphically. Okay, so we're already set up in y equals mx plus b form. So for that blue equation there, 3x plus 6, I'm going to start right at 6 on the y-axis, and then I'm going to go up 3 over 1, up 3 over 1, and I'll get my line. Then for the green graph here, negative 1/2 x minus 1, my b value is negative 1. So I go down on my y-axis to negative 1, put a point there. From there, I'm going to go down 1, right 2, down 1, right 2, and then that will give me this line. Okay, there is one intersection point. The answer would be negative 2 comma 0. And what I want you to start thinking about, though, is just the language I'm about to have here, where we say there's one solution and we're looking at the slopes are different. And that should sound very familiar to you, right? We've already talked about the fact that if there's one solution, the slopes have to be different. Or if the slopes are different, there will be one solution, okay? All right. Awesome. Now let's take a look at this system. Again, we're going to solve graphically, but this one, there's just a little bit more work involved. We're going to have to rewrite these in terms of y equals mx plus b. So y has to be all by itself. So in that blue equation, everything needs to be divided by 4, so that's going to give me 2x minus 4. In the green equation, I'm going to take my negative 16y, and I'm just going to bring it right over to the other side of the equal sign. That means it'll become positive 16y. Then everything has to get divided by 16. So that's going to give me y equals 2x minus 4. Now, most of you are going to look at this right away and say, hey, those are the same equations. And if they're the same equations, that means you have two lines that are directly on top of each other. And so that will mean we have infinite solutions. So here's the blue one. And then when I draw in the green one, you can see it's right on top. And we say there are infinite solutions. The lines are overlapping. Now, if we were to compare the equations, here we see that the slopes are the same and the y-intercepts are the same, okay? Okay, try this guy. Now, most of you again, sorry, most of you again, just looking at this, will say, hey, the slopes are the same, but the y-intercepts are different. That gives me parallel lines, okay? But go ahead and graph it just for fun and for review. So I have a y-intercept at negative 3, and then I'm going to go up 1 over 3, up 1 over 3. And then I have a y-intercept at negative 5, and I'm going to go up 1 over 3, up 1 over 3. So there is no solution here. The lines are parallel, and then when I go to compare the equations, the slopes are the same, but this time the y-intercepts are different. If the y-intercepts were the same, I would have been back to the last slide where it was the same equation and they would be overlapping lines. Okay, all right, so was there a quicker way to determine the number of solutions to the system without graphing it first? And yes, there is. We can just look at the equations. So how can you tell from the equations that lines are parallel, the slopes will be the same, but the y-intercepts will be different? Okay, how can you tell from the equations that you have the same line? Well, they have to be the same thing. So the slopes will be the same and the y-intercepts will be the same. Okay. All right, why don't you need to identify the y-intercepts to show that there's only one solution? Because as soon as the slopes are different, at some point, they will cross. okay? If the y-intercepts were the same, they just happen to cross out the y-intercept. If the y-intercepts are different, they happen to cross out a place that's not the y-intercept, okay? So as long as the slopes are different, there will be one point of intersection between the two lines. It doesn't matter whether the y-intercepts are the same or not. Okay, so we're just going to kind of summarize that into this cute little table. So two lines that are intersecting, the slopes will be different. The y-intercepts, it doesn't matter. Yes, the lines will intersect and the number of solutions will be 1. Okay, see if you can fill out the next row before I do. So two lines to have parallel, the slopes will be the same. The y-intercepts have to be different here. The lines will not intersect and the number of solutions will be none, 0. And then a coincident, that refers to the overlapping lines. So the slopes will have to be the same and the y-intercepts will have to be the same. The lines will intersect, they overlap each other, and then there'll be an infinite amount of solutions. Okay? Awesome. All right, so now I have given you the equation y equals 1/2 x minus 7. Create a system that has, so you're using this guy here as your first equation, and you're gonna write a second equation so that you form a system that has one solution. Then you'll write an equation that will form a system with the first guy that has no solutions, and then you'll write an equation that will form a system with the first guy that has infinite solutions, okay? So if I want one solution, all I have to do is change the slope. Well, this is already in y equals mx plus b form, so I already see, hey, I have a slope of 1/2 here. I can write anything I want here as long as it doesn't have a slope of 1/2, okay? So I wrote 3x minus 7. It totally doesn't matter, okay? 50 of you watching this video could have 50 different answers. It doesn't matter as long as the slope is not 1/2, then you've created a system that has one solution, okay? If I want no solutions, okay, so now no solutions means parallel lines, which means the slope has to be the same, but my y-intercept has to be different. So I'm gonna pick on this -7 now. I want to keep the 1/2, but I don't want -7. So I can write anything else as long as it's not -7. So I randomly chose +5, doesn't matter. Now, for infinite solutions, I need the same line, but I want you to have a little bit of mathematical thought there. I don't want you to just write the exact same equation, do something to it. So maybe you want to multiply everything by 2, get rid of the fraction or something like that. Or maybe you want to multiply everything by 10 or divide everything by 5, doesn't matter. But give me something different. So I chose to just take that original and I multiplied everything by 2, and that's what I wrote for my second equation that would have infinite solutions. Okay? Awesome. Okay, so now take a look at this, analyze each system to determine the number of solutions. Now, I want you to be very careful with the wording here, okay? It said determine the number of solutions. It didn't say tell me what those are, okay? So that's when you know you just want to be comparing the slope and you want to be comparing the y-intercept. That's the sort of answer I'll be looking for. I'm not looking for you to solve this by substitution or solve this by elimination, okay? I'm looking for you to write it as y equals mx plus b, and then to talk to me about what you see about the slopes and the y-intercepts when you compare them, okay? So for this top guy, 2x plus y equals 6, I need to write that as y equals mx plus b. I'm going to bring the 2x over, so it'll become -2x. So that will, oh, sorry, my mouse wasn't on. That will be y equals -2x plus 6, okay? And then for this guy, I need to bring that -8 over, so that'll be -2x plus 8. So now I look at this and I say, okay, my slopes are the same, but my y-intercepts are different. That tells me I have parallel lines and there are no solutions, okay? Tells me I have parallel lines and there are no solutions. I need to see both of those statements, that there are no solutions and that the lines are parallel. And I need your reason behind it. Your reason behind it is that the slopes are the same, but the y-intercepts are different, okay? All right, try this guy. Well, they are both in y equals mx plus b form already, and I see that I have different slopes. So as soon as I have different slopes, I know there's gonna be one solution. Oh, sorry, so the slopes are different. Right away, I can just say there's one solution, okay? All right, this guy, you're gonna have to do a little bit of work to rearrange it so it says y equals mx plus b. So for the top one, I'm going to bring that negative 6 over here and the negative 12 over here. So that's going to give me 6y equals 10x plus 12. Sorry, I did it the other way, but that's the same thing. It's just all mine are negative right now. Divide by negative 6, you'll end up with the same answer. Y equals 5 over 3x plus 2. Okay, now the other guy, the 21y equals 42 plus 35x. I need to divide everything by 21. And when I do that, I get 5 over 3x plus 2. So now I see I have the same slope and I have the same y-intercept. Okay, so these guys are overlapping lines and there are infinite solutions. Okay, so it's all about comparing, so writing it as y equals mx plus b form, and then comparing those slopes and comparing those y-intercepts. Okay, and that's it for today. So I've given you some work to practice. Make sure you're communicating to me, okay? Make sure you're talking about not just that there's one solution, but why you know there's one solution. That's what analysis is all about, okay? You have to communicate your knowledge to me, okay? So have fun with this. Have fun studying for your test. And as you go through all of this, if you have any questions, as always, please connect with me, okay? And then we'll see you for the next unit. Take care, guys.